Okay, all right. So now we're going to look at actually constructing some different charts based on categorical and numerical data. Here we have a chart that is based on, ideal distance for parents and students. Um, what they would consider to be that. So we're going to make this graph. Um, Now, the important thing is, because these frequencies are all different, right, it doesn't really make sense for us to graph them that way. The only time it would ever make sense is if the frequencies are exactly the same, or if they're polled in the same way, which obviously here they are not. So we need to make sure that we use relative frequency because that's a better indicator of really the weight as to where things are going. So we're going to make our top chart. This is going to be relative frequency. And this goes from 0% all the way up to 100, or 0 to 1, whatever you want to think about. 0.5 in the middle. And then on the bottom, we have our different categories. We've got, you know, less than 250. We've got between 250 and 500. We've got between 500 and 1,000. And we've got over 1,000. So we're going to make these, and we're going to draw in these two different ways. So we'll call students blue, and we'll call parents green. So we'll go through and make the students real quick. So the students, 35% are going to be less, so we're about right here. Okay. Um, Students are then go to 31%, so a little bit less. They then go down to 19, so pretty small. And then we have 15% finally after 1,000. So just roughly drawn. I mean, it's not perfect, but you could make it a little bit better. Now, the reason why this is good is like we're going to go through and we are going to now graph the parents. Well, parents are at 53% here, so a little bit over 50. So we've got a good difference there. Here they're just slightly lower at 30%, so just slightly lower. Sorry, I'm going to color that in because I messed that up. Then we go to 11%, so like quite a bit lower. And then 6% finally at the end. Very, very low. But this gives you an idea of kind of how these two different graphs compare. And again, it's very, very important to use the relative frequencies to do this. Most of the time they'll be given to you. If they're not, then you'll have to find them on your own. If we do the same thing with pie charts, we don't really do a comparative pie chart. We just make two. So we'll have our, parents and students, and we're just going to label them with different colors. So we'll have this one be blue, we'll have this one be purple, we'll have this one be green, and we'll have this one be red. So we just go through and we're just going to label these off pretty quick. For blue, and it doesn't matter which order they're in either. For blue, less than 25%, so our parents are at 53%, so we're almost half, just a little bit bowed out. And our purple is going to be at 30%, so it's less than a third. Actually, that's not good. So less than 30%, so it's more than a quarter. So we're like here. And then we have 11% and 6%, so very, very small. So we can kind of see a good breakdown there. For students, um, you're going to use this data here. So we need 35%. It's a lot more uniform for the students. Students have about 35%. So no, no, maybe a little bit more. 31% gives us our purple. And then we have 19 and 15% for green and 15% here. So, I mean, these are just rough eyeball sketches of these. But, you can see the difference between how these graphs are kind of approached on both ends. But these are, again, both graphs that you're going to use for categorical data. And more specifically, you need to make sure that you're using relative frequency to take care of this. Um, okay, and then obviously you can break this down in the circle however you need to, but most of the time you don't draw these by hand. You would use a computer program to exactly find the right amount for yourself. Um, Now, segmented bar graph, we're just going to do this for one of these real quick. Segmented bar graph is just like a bar graph, but kind of like also rolled into a pie chart. Very interesting. Um, we sit there with 0% and go up to 1, and again, just like we did before, where we had under 250, or, oops, excuse me. And we're going to have, I said that incorrectly, we're going to call this our parents graph, because this is just all for the parents. So we're going to do it pretty much the same as we did on the last slide. Let me see the colors. Blue, purple, green, red. So we got blue, purple, green, and red. Here's how this is going to work. We're going to start off with the less than 250,000. So for parents, that's 53%. So we're going to go up to 53% with blue. Next, we're gonna stack on top of that our purple, which is the 250 to 500 miles. Now that goes to 30%. So we need this to almost 80%. So we're going to call that here. So this is kind of an interesting model because you can see that, these first two categories almost account for everything as it accumulates up as we go. So this could be an interesting one to kind of prove a point, where data lies and so on, so forth. Then next we have 11% is going to be green. So very small. And lastly, super tiny, we have red. And again, this isn't exactly perfect, but hopefully you're seeing the idea. That this is also giving you a picture. It's just like a pie chart, except it's all in a bar. So that's it. There we go. Then we got stem and leaf. So stem and leaf, I'm not going to plot out a ton of these, but I will do my best. This is about average tuition. So they're doing these in the thousands. Now this is really hard. It's always hard to decide how you want to actually go about doing this. But we are going to write this out in the following way. So it looks like our smallest, at least in the thousands, is going to be 2. And so we're going to write 4, 5, 6, 7, 8, 9. And it's important to write that this is, oops. It's important to write that this is in the thousands. Okay? Now, this is going to be, the rest of it's going to be in the ones, because that's just how it works. Okay? So from here, we're going to write out different numbers. So we start off, our first number is 4,712. So we're going to go to 4,000, we're going to write 712. And it's important to put a comma just so you know that the next one's going to be a different observation. And then we move on, we got 4,442, so we got 442. And we got 669. And 937. And 452. and 634. And yes, we're on a roll there. We don't seem like we're getting a whole lot of extra room here, but you get the idea of kind of where to plot these. I'm going to run out of time trying to plot all these, but that's what you need to do. It's basically decide the best way to sort these. Now, if you would have gone down to like the hundredths place, that could have been really ugly, and you'd have it stretched quite far. But picking the thousands in this case made a lot of sense. And then lastly, you have a comparative stem and leaf plot. This is where you're going to draw to the left and right of your data. So here we are going to have, we're talking about primary school age children who are enrolled in school, or the percentage of them. So, and this is Northern Africa versus Central Africa. So you can kind of see the distributions based on each of these. So it looks like we've got a 30 here, a 30 here, and we've got up to the 90s. So, we've got some large ones. So we're going to say that this is our tens. We're going to start with 3, and we're going to go 4, 5, 6, 7, 8, and 9. And we are going to drape this over. Now, we're going to call this one Northern Africa, and this one Central. So to make this comparatively, we're going to go down the line, and I'm just going to do one by one each side. So this is a 54.6. So normally you could do a 4.6 over here, or you could just round. We can round that to a 5. No big deal there. Or you could round down. It's either way. It works both ways. So you'd have a 54.6. We can call that a 55. Now we have a 58.3. We'll call that a 58, but that goes on the other side. Okay? So you can see that, Northern Africa goes here, Central Africa goes here, and we just compare them as we go. So we got a 34.3, so we'll call that a 34. And we got 34.6. Call that a 35. And so on and so forth, and you add down the list as you go. So it's just mainly just the setup, deciding which you're going to have in the middle, and then completing the problem.